We're looking at proportional reasoning, and the method we're going to use is equivalent ratios to solve this question. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to represent using equivalent ratios and proportions directly proportional relationships arising from realistic situations. So here's our inquiry type question. We'll read through it once and then highlight the important stuff the second time through. On a sunny day, a flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. At the same time, a tree beside the flagpole casts a shadow that is 4 meters long. How tall is this tree? Okay, so let's highlight our important stuff. Any info about the flagpole I'm gonna highlight in yellow. On a sunny day, the flagpole is 6 meters tall, and its shadow is 2.4 meters long. At the same time, a tree beside the flagpole casts a shadow. We'll do this tree in green. A shadow that is 4 meters long. How tall is the tree? Okay, so here's our information. Because it's describing a picture, I'm going to try to recreate this picture. So we have our flagpole. I'm going to use this to represent our flagpole, and I'll do gray to represent the shadow of the flagpole. Okay, and it said that the flagpole itself was 6 meters in height, and the shadow cast was 2.4 meters. Okay, so here's our flagpole. And there's a tree, whoops, there's a tree directly beside it. Again, let's use a tree. This time we'll represent the tree in green. I'm going to make the tree a little taller just because they said that the shadow of the tree was a bit longer. And if the shadow is longer, we can kind of go on the assumption, if all other things are the same, that the tree must be a bit taller. The shadow itself was 4 meters long. Here's our tree. Okay, so this is our unknown, and we can use x to represent that, the height of the tree. Okay, and we said we're going to use equivalent ratios to set this up. Okay, so our equivalent ratios. We have our flagpole category and our tree category. Works out great. Okay, so though we can't see it there, I'll write it again. This is our flagpole section and our tree section. And we have height, and we have shadow. Okay, so if you notice, I've set up 2 columns and 2 rows to help me organize everything here. Okay, and we're going to do equivalent ratios. We'll use them almost like fractions here. So here's our flagpole. The flagpole height, we were told, was 6 meters. Okay, and we just need the actual values of everything. And the shadow's distance was 2.4. Okay, because assuming the angle and everything else is the same, these are similar. They build what you can turn into, tap it out, similar triangles. Okay, and similar triangles are equivalent ratios. So we can set this equal to the height of the tree. We represent it with x, and the shadow of the tree was 4 meters. Okay, so now we've set up an equivalent fraction. Now, I do want to show you, this looks pretty straightforward. It doesn't have to be set up exactly this way. Maybe I decided, and I'll do it in red just over here, use a little line to separate. So this, so you see that our steps end up being the same. Say I did height here and shadow here, okay, and I'm just going to use the first letter represent, and this was maybe our tree, and this row will represent our flagpole. So the height of the tree. The height of the tree was our unknown, sorry, as we saw above. And the shadow of the tree was 4 meters in height. The flagpole shadow was 2.4, and the height of the flagpole was 6 meters. So if you notice, the fractions that kind of look very, very different. They've been set up very different. We'll solve the one in black first, and then we'll solve the one in red just to show you that it could be set up different ways. You'll still get the same answer. So we have equivalent fractions here, okay, or equivalent ratios, whichever you want to call them. And sometimes it can be hard to work with fractions. We could divide these values, get a decimal, and then bring the 4 over. But one of the common ways of solving this is to cross multiply so that we're not working with any fractions anymore. Either method will work. In fact, I'll cross multiply in the first one, and I'll divide and use some algebra on the second one. So when we cross multiply here, I'm going to multiply 2.4 times x and 4 times 6. Now, 4 times 6, I know, is the value of 24. Right? 2.4 times x, and I keep this equal sign in line. Because I can't really combine those to make them any simpler, it's 2.4x. Anytime we write a coefficient in a variable, it means multiplication. The goal is to isolate for x. We want to know what the height of the tree is. So I need to divide both sides by 2.4. Okay. A lot of times they call this canceling out, but it's essentially reducing this value to 1. So now we only have x on the one side. And 24 divided by 2.4, we can use our calculator for this one. Okay, you'll notice these values, they almost look the exact same. 24 divide 2.4. Because we're dividing by that, it ends up being a value of 10. Okay, so this x says that the height of the tree was 10. Okay, now let's go through this. We've set up a different ratio. Now we're going to try to solve it a different way. Let's see if we get the same answer. Instead of cross multiplying off the bat, I'll actually divide these values. So we'll end up with a decimal. So 4 divided by 2.4 equals 1.666. So now we're going to end up doing a little rounding here, which may get confusing, but I want to keep this number as accurate as possible. I could just round to one decimal place, but you'll see in the end that'll give us a very, very different answer. I still have x divided by 6, and I need to get x by itself. So because this is divided by 6, in order to create a 1 again, technically what we're doing is multiplying both sides by 6. Okay, but sometimes they call it bringing over and multiplying by 6. Really, again, it's creating a 1 on this side. They call it canceling out, but we created a 1 once again. So it's 1x, or just x, is equal to. And I'm going to take that value from before. Luckily, my calculator keeps the old value, so I'm going to keep it as try to be as accurate as possible, okay? Times 6. Now, be aware, this calculator already did some rounding. You'll notice our answer, luckily ends up at 10. If I had rounded it, just to show you, to 1.67, let's say, and multiplied by 6, I got a 10.02, which isn't quite the right answer. So we want to be as accurate as possible. And probably the best way of done this was the first way of cross multiplication. But again, we ended up at the same answer. The tree's height was 10 meters. Okay. If you'd like to see other methods to solve this question, you can check out our other playlists on proportional reasoning.